Problem number 1911, maximum alternating subsequence sum. The alternating sum of a zero-index array is defined as the sum of the elements at even indices minus the sum of the elements at odd indices. For example, the alternating sum of 4, 2, 5, 3 is 4 plus 5 minus 2 plus 3. Given an array of nums, return the maximum alternating sum of any sequence of a subsequence of nums after reindexing the elements of the subsequence. A subsequence of an array is a new array generated from the origin array by deleting some elements or no elements without changing the remaining elements relative order. For example, 274 is a subsequence of 4, 2, 3, 7, 2, 1, 4, while 2, 4, 2 is not. Okay. Okay. Okay, so the first question is how, the size of the nums. Okay, it will be at least one element, and the range of each element, it will be at least 1. Okay, so it will be positive integers, so it will be 1, and the answer will be 1. Okay, so the example 4, 2, 5, 3. So when we when we look at 3 and trying to find the maximum alternating sum of its subsequence, okay, so for subsequence we can think of there are two ways. We can iterate every subsequence ending with 3, or it would I think it would be easier to do choose or not to choose every element, and but it will be the thing is the index will be changed when it is lagged into a group, and okay, so first of we can, if we don't choose 3, or the other option is we don't, let's say if we choose 3, so the problem will become finding the maximum alternating sum in the previous rest of the array. Then yeah, I'm trying to think of a way to yeah, to keep track of like whether the current element has to be minus or plus. Or maybe we should do both. But yeah, I'm thinking of like if picking the neighbor elements and their operands will differ. Like if I pick 3 as plus, then for 5 the neighbor elements will definitely be minus. But if I pick 3 as minus, then for 5 it will definitely be a plus. Okay, let's say if selecting norms I, the problem will become finding the sum in I'll say if selecting norms I, the max sum will be equal to will be equal to the previous ones plus norms I plus or minus. And if not selecting norms, then the max sum will be the previous ones. Okay, so I think we may need like positive and negative added as a parameter, right? Representing a state, and and so that we can know like the next state or the previous state, what should we do. So I will still, since the problem is shrinking, like, and it is repeating the same problem, so we can use dynamic programming, and I will start with a recursion that is depth first search, and I will call it DFS, and having the parameter I, and I will say A, the alternating thing. So A will be 1 or 0, indicating positive and or negative. So there will be DFS I 0 and df as I1. Okay, so df as I will be the alternating sum from nums 0 to nums I with a with the state with with the expectation of finding negatives or positives. Okay, so for dfs I0, it will be the maximum between don't select. So the previous maximum sum will be dfs I minus 1 with it will stay with the 0. Yeah, I think this will be like the last element is or the current element is 0 is using minus, so this so I want to find a negative value now. Okay, and another option will be dfs I minus 1 with previously 1, so that the current will be 0, and you can with 1 we will add, we will minus, since currently it wants a minus, a negative. And for ones, for positives, it will be plus, and it will become from a 0. This will be continue as a 1. Okay. So the time complexity for this, since a is small, so we can see as a constant. So the time complexity will be O(n) since I has a size n. Okay, let's start with having n equals the length of nums, and we will have the recursion dfs. We will do the boundary stator. So let's start. So if a is 0, then return maximum. Okay, we can copy this, and else can I have an empty thing, empty subsequence? Okay, it doesn't set, but I think if nothing is selected, then it will be 0. So it is not, it's not worth it. Yeah, so there is don't select and select. And for the boundaries, so since I don't want I-1 to be out of bound, if I is 0, there's still I think I will return 0 as a default value. Okay. And for the answer, it will be return DFS and -1 with I think 0 and 1 should be all included. And we will have a maximum. Okay, let's add a cache. Wow, cool. And yeah, for optimizing, but not optimizing, but I can change it to a for loop, iterative method. So the first thing that I had to do is creating a matrix that will be max order, and we will have A with the size 2. We'll have 0 as a default value, and and with n rows. So for I in range n, maybe we'll have n plus 1, then to have a dummy node, and this will be max alt I, and if A is 0, then we will have maximum max alt I with 0 with don't select, and max order having stacking, and minus nums I. This will be plus, and this will be 0. This is 1, and this is 1. Oh, sorry, this should be I plus 1 since we have a dummy node. And return maximum between max alt and 0 and max alt and with 1. Dummy node, okay. Cool. Then since this I plus 1 and I, it only use 2 rows, so we can optimize to O2 space, O1 space, so we can have alt 0 equals 0, alt 1 is 0 as will be 0 as a default value. So this will be 0, 0, 0, 0, alt 1. Yeah, I write it in the same line so that the value will not be covered out. Okay. Okay, great.